Thank you for coming, Slava. Great to have you here.
Yeah,
For
thanks.
those who don't know, Slava is a veteran software engineer of everything that has to do with data repository. He's been active, leading contributor in having the Dataverse repository model that was initially built out in Harvard to be adopted across continents and building out all of the necessary infrastructure, also localizations and all of the things that would allow for adoption of that pretty awesome repository tech, across the ocean. And so Slava's been like one of the key figures spearheading that effort. So thank you, Slava, for joining us
Mm.
today. Much appreciated.
Thanks
Yeah,
for,
thank
for
you so
such,
much.
such a nice introduction.
Yeah,
Ah,
and actually, with that introduction, we may as well start, and people can trickle in as time goes on, if that works for you, Slava.
okay. Okay, let me see if I can share my screen. Can you see something?
Yes.
Yeah, we can see it.
Okay, that's great. Yeah, just let me put my, yeah. Okay, so yeah, that's true. I was quite like one of first contributors probably to Dataverse in Europe, and in that time we only had Dataverse in Utrecht, which is in Netherlands, and we took it as a service. And after we decided to make it international, so we invited 12 partners from Europe to contribute translations, and after it just became the most popular data repository, one of the most popular data repositories in Europe. And I think currently it's like we have 48% of installations in Europe against 28% in US. So we're kind of growing, and now everybody's switching to Dataverse. Anyway, so my presentation is about Dataverse, but not really about Dataverse. It's about knowledge graphs, and we are just moving Dataverse content in knowledge graph, and also we're using large language models as a kind of AI behind helping us to connect all these data points in knowledge graphs. So just to start, all this work is funded by Odyssey, and this is Dutch national infrastructure for social sciences. And the idea that we want to build semantic search. It's a kind of big thing. And the way how we are going to do that is really based on knowledge graphs. It's not only embeddings, but we really want to build a sustainable infrastructure. And we want to find all data in any kind of language. For example, if you're searching in Spanish or in Italian, you should be able to find all data sets in Dutch as well. So this is what Odyssey is about, and we have first releases, very successful, and currently this infrastructure is being considered by Dataverse and global Dataverse community to actually to bring together all instances. And probably after we'll get Croissant, so we'll get data from Kaggle, Hugging Face, and other data providers also inside of this infrastructure. So before I will start to tell about knowledge graphs, I wanted to, of course, this paper. I wanted to introduce it again. It's called Attention is All You Need, and it was published by Google, of course. And what is really remarkable about this paper, you have attention mechanism here, because it's very limited window where you can put context inside of large language models. And attention basically defines how prompt will be resolved and how large language model will start to produce response to you. So in this configuration, attention is the most important thing, and we are basically using knowledge graph also to kind of leverage attention and recognize important words, also like detect keywords, remove unnecessary parts, and make more weights, assign more weights to really important words. Also, this is quite important, and this is something I'm using from the very beginning. I'm Ukrainian, so I basically coming from the old Soviet Union school, and I'm using TRIZ, which is theory of inventive problem solving. And this is kind of theory which was created by Soviet engineer named Henry Altschuler in 40s during Second World War. And basically, if you'll take a look on this, it's kind of first ever known LLM because it has all principles of innovation. And you can combine few principles together and you can get something new, some new sometimes completely new things. For example, if you want to build something, you can use you can freeze water and you can get building blocks from ice. And if you're able to keep temperature low, you can just use it as building material, something like that. So all of that also applicable for LMs. And I started to use it kind of for chain reaction to make LM act as unstable systems. So on this slide, I think it's quite nicely explained that if you want something like fission in nuclear physics, you're combining isotopes, uranium and plutonium, and after basically just going to fission. And I'm doing the same. I'm using this as kind of chain reaction, and in the end, it's not going to atomic explosion, but it's making LM not stable, which is what we want, because as you know, in LM you have compressed knowledge, and all this compressed knowledge is kind of packaged in one file, and this file should be kind of also transferred to unstable state to fit your question in more accurate way. So what we discovered, and we did quite a lot of experiments, we started to introduce kind of randomness inside of prompt, which means that you have to combine meaningful words with some buzzwords, and after you can get better results, which is kind of contradiction by itself. But if you'll think about this, how it works, instead of having like clusters in vector space close to original prompt, you can actually get much more clusters which will be better corresponding to your original prompt. So just think about this, and I will leave it for now. So what is everything data? Everything data is framework that I've created for Odyssey, and now it's getting integrated in a couple of other projects, both national and international level. For example, we have Music project, which is about using AI for music. So we are building also a registry of all compositions of all songs, so all music basically produced by humanity. And we're also using AI for that. And basically, it's API-based service on top of LM. And it can do a lot of useful stuff. For example, create SQL tables from files. It can also decompress LMs with knowledge graphs. It can recognize semantics. It can do natural language processing. So all this stuff is, like quite common for modern LMs. But also it can connect to Dataverse and, for example, use metadata to get better enrichment, and also it can extract variable level descriptions from just descriptions in file metadata and just normal metadata. And also it supports linking of variables in semantic web concepts. And last functionality is quite remarkable because it can also generate complete control vocabulary based on some input page. For example, if you have Wikipedia, you can just decide from which Wikipedia page you want to extract all ontology, all relationships, and after it will do job. I will show you how. So this is a link if you're interested. It's on GitHub, it's open source, and you can run it if you have a powerful GPU, hopefully like A100 or even more powerful. Anyway, so first use case is automated translation of control vocabularies. And in our project we have Dutch metadata records. Also, we have English and some other languages. Anyway, Dutch is kind of probably 80% of what we have. And we want to connect, to link keyword fields, for example, to some ontologies and control vocabularies. So what we do, we are basically getting from keyword field all these variations, and we are using description in Dutch as a context, and we are sending to this framework, and basically we are getting all translations in the context of specific keyword. So this keyword, after it will be ingested in control vocabulary and also in search engine. So this is where you can search already in any language, and you still be able to find metadata in Dutch. No problems with that, and it's already working. And second use case, this is what I already told you. So we are enriching control vocabularies with voice translations, and basically we're publishing new revised version of the same control vocabulary with adding hundreds of translations. So you can get quickly like 100 translated terms, and this information is available and is basically quite good already. However, they're still busy with evaluation, but it looks like we're getting like probably to 90% of correct translations, which is quite good. So this use case I already mentioned. For example, if we want to generate quickly COVID-19 taxonomy, so we will use Wikipedia page as input. And after half of hour, after artificial intelligence will do all job to recognize all concepts and all relationships between concepts, it will produce completely full ontology, which is already published in Cosmos framework. And Cosmos is a hosting platform for control vocabularies. So we can turn any Wikipedia page very quickly in something meaningful. And we already built control vocabulary integration before, like 3 years ago, we contributed to Harvard Dataverse. So now, as soon as it will be in this control vocabulary, it will be also available in Dataverse interface. So instead of just using free string to find some control vocabularies, you can just type for a few characters and you will get list of suggested terms coming from this control vocabulary in any language. So this is kind of great functionality also to create linked data. So next use case, I think is even more fascinating because this is a way how we started to decompress knowledge from large language models. So we're using kind of knowledge graph miner, and we're sending sentences from any text. And like in this example, it's about COVID-19, about symptoms, and you can see it's extracting facts like fever, symptom, and it's an overall part of COVID-19. And we are recognizing a standard ontologies like obvious, OVL's cause, and some others because this is how model was trained for. So we are using Llama, we are using Mistral, and apparently they started to feed structured data inside, and this information is already available. We just need to know how to get it back and in specific context and recreate this knowledge graph. So this is great because first it allows also to enrich metadata with new relevant terms. And second, we are getting all relationships. So we can also put this in triple store, and by running Sparkle queries, we can get all information. Another use case, and this is also quite interesting. So we have a Central Bureau of Statistics, is statistic agency in Netherlands, biggest one, and they have data about FN, and they're dreaming to build AI assistants, but they want to do slightly different from what ChatGPT does, for example. They want to generate SQL queries to support their researchers, and researchers will be in charge to run those SQL statements. And the idea that probably they should be able to combine hundreds of data sets about different topics and just with SQL query to be executed and get kind of new data set out of it. So this is what LM also does in very draft version. So you can see I'm using like the Titanic passenger survival data set to illustrate how it's producing a SQL statement. And next use case is also quite interesting. So it's also continuation of AI assistant. Apparently, if you ask assistant about questions that you can, questions could be answered by your data sets, it's also possible to get a list of, well, predicted questions, which could be also integrated in dataset metadata. And it's very valuable information for any researcher to understand on what kind of questions it can respond. So it's also quite interesting, and I believe this is kind of future for any kind of studies. So where do we go from here? I already mentioned to you for you Sparkle, and Sparkle is a query language for triple store that we're using. We're using Cosmos, and Cosmos is consisting of Jenna Fuseki and API interface, which is built by National Library of Finland. And Triple Store is open source project. It's Jenna Fuseki. So basically, as soon as you will install Cosmos, you will get really nice Triple Store, which could be optimized also for different use cases, and you can get Sparkle queries executed. So this is like perfect infrastructure to be connected to LLM and to everything data to get everything inside of what it's basically producing. So VCI generated graph on data management topic. Why it's here? So everything data also is able kind of extract from LLM some hidden information like hidden relationships. So you can see in this example, it has cause, it has, well, OVL is not shown, but this is also part of what is responding. But also you can get some interesting relationships, like in this specific case, you have better data organization, enhances research productivity, increases research efficiently, used for knowledge organization. So basically, if you will see in this namespace, it's just collecting kind of synonyms or related words, which could be also used as a kind of AI-generated ontology by itself. So it can help to structure knowledge, and it's quite useful even in the current state to be understandable by human, not only by LM or any kind of machine. So this is great, and I believe in the future we'll use this to produce AI-powered controller categories and ontologies, which will be fully structured and reusable, and probably will suit a lot of use cases. And all this information also, we are using kind of in summarization mode, because it can be used for in prompt for Sparkle, and it can be used also for LM itself. So what we are doing, we are just recognizing all available ontologies in our knowledge graph, and we are feeding this information to LM. And after LM, it just understands which language it should talk. So this is also quite interesting. So now I'm coming to the point where LM can be, knowledge graphs can be used as supervisor for LM. And to be honest, I was one of the first people probably tested GPT-2 in 2020, 4 years ago and something. So one of my friends, he introduced me to LM stuff in that time. And what he was talking, it was quite amazing to hear that in the future, you should be able to talk to your own data, like just you are talking to human. So let's see how it's possible to do with current developments. If you'll take a look on Llama, but yeah, probably the same works for ChatGPT. It's really good with historical facts. As soon as you have information inside, and you can just feed any kind of fact, and after it will recognize and will answer. However, it should be just there. And if it's not there, and if you're asking question about some information that is not in part of the training set, for example, Llama was trained in 2022, and I was asking question about Eurovision Song Contest winner in 2023. So model is responding that it doesn't know because it was trained before. And what we can do about that? So I started to build kind of my own Google, of course, based on Dataverse. So in this French University Paris-Cité, Sorbonne, we started to build a research engine. And also it started to attract different use cases from European projects. But basically what we're doing, we're building knowledge graph based on any kind of information. And we're not taking, we are not storing full text and any kind of copyrighted information. We are basically extracting relationships and building knowledge graph, which is what we are using for answering questions like who was the winner of Eurovision last year. So this is just how it looks like. It's event registration. So you can have title and a small description and list of keywords. And there is also like hidden layer with knowledge graph itself. And if we'll use this approach, prompt will look a little bit different. So instead of asking directly who was Eurovision winner, I'm basically trying to put LM in a reasoning engine mode. So I'm basically asking, can you give me please list of keywords which considered to be important to answer this question? And this is something that we also like using for with knowledge graphs. So final query, this Sparkle query will look like that. So we'll put all stuff in here, and after we'll get direct answer from news, which was published on one of the sources, that Sweden wins Eurovision Song Contest 2023 with Tattoo by Lorraine. You see, so there is no interpretation from LM. It's just giving you back the fact which was written down somewhere in internet. So there is no space for hallucination. It just basically, if it knows right keywords, it's just answering to you. So now we can go a little bit further. And in Dataverse, we're using different standards. I already mentioned croissant, but there is also OE or AE standard for open research, open, how it's called, open archive repositories, something like that. So you can just go to Dataverse, export all metadata as a kind of XML, and you can feed it back to large language model. And apparently, because it was trained already on this stuff, it just recognizes all fields and it knows how to do interpretation. And it's able to also to generate Sparkle query by itself without human. So in this example, I'm just getting result in Sparkle query after asking just to create it. So you can just imagine that this LM, it knows structure, it knows how to create it, and it knows how to query it. So this is kind of great development, because now instead of using and spending hours to create Spark query, we can also use LM to help us as a kind of assistant. And apparently the same thing is working for ChatGPT. GPT probably was trained on the same sources. So if you'll put this kind of question to ChatGPT, it will respond you with Sparkle, with Dublin Core, and you can use it to query, for example, Dataverse. So all this stuff is working. So now we're coming to the question how to make this AI-generated data persistent. And this is highly related to decentralization and DPID. And of course, you know what DPID is, but I wanted to concentrate on, in general, concept of decentralized identifier. So we can use the idea to build really fair decentralized data network for any type of the content. And this is important for Dataverse and other data repositories, because in those repositories, we're mostly storing some data sets, sometimes images, sometimes video, but it's not about storing web content, which is much more interesting, and we can get any kind of content inside. So we can use the IDs as a kind of persistent identifiers assigned to any kind of resource extracted from any web page. And this is what I just showed. In knowledge graph, we have a lot of resources, and sometimes even, you know, because LM nature is basically not stable. So if you'll ask the same question 10 times, probably you'll get 7 times the same answer, and after it will be different. And we want to put all identifiers on these kind of cases, and we want to link them together and recognize. So we want really to make sustainable data infrastructure integrated with LM. So the idea looks like perfect candidate, and also the idea can be suited for more complicated use cases. For example, to store data in hospitals. So it's kind of, you have decentralized identifier, which is invisible, and you should be not able to resolve it without having key, something like that. So there are a lot of interesting use cases. And just to give you impression, if you'll use not the ID, but like DOI, for example, from data side, and we're going to assign those identifiers to every concept from control vocabulary, it will cost us a lot of money. And if you'll use like the ID as a kind of component provided in the decentralized network, it will be for us for free, and only we need to pay for maintenance, basically. So typical problems of centralized identifiers, of course, you all know. I will just mention that it's quite difficult to recognize two authors with the same name mentioned in the different papers, if it's the same person or not. So you need to do quite complicated graph analysis on the graph network. And it's very difficult to assign paper to specific person with ORCID without knowing the fact that it's original author. And I've discussed also with ORCID, and they said, yeah, this is kind of a problem. We don't know if it's actually the person with our ORCID number. It could be any person. And some people also can claim their false authorship based on this, right? To get more credits. So there are a lot of problems, and you know, can email can be considered as identifier? What will happen if person will move from one institution to another institution? How we will keep it persistent? How to track this person? how reliable is ORCID database. All these problems of centralized identifiers we can also solve by building knowledge graph in decentralized network. So another problem with control vocabularies, I already mentioned that we started to generate those control vocabularies automatically by AI. And in this example, it's ELSE thesaurus for social sciences and humanities. And the problem here, because it's a community called CESDA maintaining this thesaurus, and they're sometimes adding more translation, more properties into this, so they're changing it. But some other people, like we are dance, we're just downloading previous version, and we also want to run it as a service in our place. And we don't know which version we are running. We are just getting something, and it's not really sustainable. So we are getting a few concepts published in different places, and we have no information about versioning, for example. And this is also that something can where DID can help if you assign unique DID to every concept and link them together in knowledge graph. So decentralized identifier really looks like a possible solution, and there are like core features. Of course, you know about that. It's like permanent persistent identifier will never change, and resolvable identifier also can you can attach some metadata to it in a context. And of course, this is very important. You have private and public keys. And decentralized identity means also that you don't have centralized party like DataCite controlling everything. So this is also quite relevant. But there are also some concerns about DID. And first of all, we had, by the way, a lot of discussions in DPID group about concerns. And I would say the biggest concern that you're kind of giving away all control. So it's going to the network, to the nodes, and it's basically a situation where organizations like DataCite and some others, they're becoming really scared because you're kind of taking all power from their hands and distributing in the network. So selection of technology also can be kind of, different based on your use case. Sometimes centralized technologies work better, and you should really consider like maintenance cost and some other things. And also you should think what will happen if you lose private key. And basically it means that as soon as it's being lost, there is no way to get back access to your data. So these concepts of digital wallets is basically becoming really important for the ideas, and it's impossible just to move on without solving these kind of issues. And basically automation of trust with DID technology also means no human in the loop involved. And this is considered by a lot of organizations as risky in the long run. So there is a place of DID as a unified resource. It's basically you have URIs, URL, and URNs. And I believe in near future also it will be supported in browsers. So instead just put in HTTP or HTTPS, you should be able to put DID in, and the browser will resolve to get you to the appropriate resource. There is also an example with private and public key and service endpoints. And to be honest, service, I found really nice feature of decentralized identifiers that you can put the ID on a service instead of just a simple resource. And you can also services different parameters and attributes like here, like parameters like here. So you can just, if you have some object containing, I don't know, JSON LD or XML or any kind of schema, you can also kind of resolve to different representation of the same data. So also I should mention that decentralized technology is not the same as blockchain technology. I know, well, for DPID it's a little bit different, but we're also using a method called audit, and it's kind of lightweight implementation of decentralized network. And basically you can just get it installed in your place as a component and run local installation. And it does exactly the same as like real blockchain technology, but it will be faster, and it will be probably the same. It will have the same reliability because all principles are being reused. Also, there is universal resolver for DIDs with a lot of methods. So probably you know about that, and you can put any DID, and you can also get it installed in your place next to registrar, and you can use it remote in decentralized network. there is also a feature that I really like. For example, if you want, if you're a professor and you want to share some materials with your students, you can also create kind of temporary access to your DID, and after some time, it can be revoked after time is gone, and students should be able, should be ready to respond to all questions. So this is what OIDIT is already providing, and I really advise you to take a look how they implemented this, because this is very interesting functionality. So the ideas for control vocabularies, I already mentioned that we started to generate a lot of control vocabularies, and we want to interlink them. We want them to make, to add some persistency. So it looks like DPID and any kind of DID is really the right solution to assign persistent as a persistent identifier to all concepts. So probably for control vocabulary, we'll have 100,000 of concepts. Everything will get on persistent identifier. It will be interlinked. And we should be able to track all provenance information, how it was created, which kind of models we used, if people actually, human actually approved some concepts. All this information should be also linked to a specific concept and should be available in knowledge graph, in distributed knowledge graph. So I already implemented a few proof of concepts, and for example, in Dataverse, I started to assign the IDs to datasets. So basically not datasets, but to any kind of content like web page. And usually it's quite difficult to get some web page described in Dataverse, but I'm using artificial intelligence, like already shown, to extract all keywords, to generate description, to generate graph, and all of this information is getting on the ID, which is available in knowledge graph. And also what we do, because my organization is also taking care about archiving. So we are also implemented archiving layer and like service-based, like I already explained. So we can just put the IDs on S3 protocol, for example, to track revisions of the same file stored, I don't know, by AWS or Google Cloud or on Azure. This is what you can do with technology like that. So now we're coming to DPID. So I took this slide from Eric, and of course, DPID is implemented by you guys, by DeSci Labs, and it has a lot of potential for use cases that we are considering. So I told you a lot about the DIDs, but the DPIDs is quite adopted, I would say, to make readable scientific records, such as data sets or control vocabularies and any kind of information that we're generating with AI. Okay, so probably I will not take your time anymore. And if you have questions, I will be really happy to answer. Oh, I see some questions.
Thank you, Slava. That was amazing. I think there's a bright future for the interface between LLMs and DIDs, right? There's a really interesting interface here. And I could imagine a future in which a lot of the data ingestion, data curation, data annotation, and also the querying models, all of this is handled by the LLM side as the ingestion engine and representation and data representation system. And then the decentralized web technology, they serve as substrates for the preservation and the ability to query this data from multiple source points, right? So I think there's a really very fertile ground. And I love that you are so deeply applied into this domain, which is something that really is very enriching for us, because you've been in the trenches for quite some time experimenting at the cutting edge of these things. So yeah, thank you. Great presentation.
You're welcome. So
Yeah,
probably we can go to questions, and can you just basically ask this question?
yeah. I
Yeah.
think Philip was the first one who brought in a question, and then after that, we've got several other questions that we can go to after that. Philip, do you want to unmute and ask your first question?
I have my water boiler running in the background. So yeah, Slava, this is super cool. So there's so many fascinating things going on. So I had a couple of clarifying questions. So am I right to interpret this as the AI basically making educated guesses about what the knowledge graph looks like without much human input and steering?
Yeah, that's correct. We are not using any human input. We're just collecting information and
That's super useful. And do
yeah.
you guys did you test like how accurate these knowledge graphs are? So is there a sort of like a process where humans can actually go in and double check if the AI is hallucinating or like how good this is?
Yeah, so this work, as I said, is being done in Odyssey, and we have Open University in Amsterdam who is doing evaluation of our results. And I don't have like from the top of my head results at the moment, but at least like first experiments quite successful. So they already think that this information, if you'll translate to like funding, so if you want to get something like COVID-19 taxonomy, translate it in 100 languages, right? And with appropriate relationships. So probably you need to hire at least 20 ontologies for 3 years. And probably they have to spend all like full time on this. And it will cost you, let's say, $500,000 approximately, right? And instead, you can run this process, and it will do the same probably in half an hour. It will be not so accurate. However, it will be quite good already.
And then I had a quick question around the ontologies. You were mentioning bootstrapping your own ontologies from like a Wikipedia page or something like this.
Yeah.
I'm wondering, are you able to also like integrate and create like, hey, it seems like you're using a lot of words related to this ontology and suggest an ontology that you can be like backward compatible with as someone who's written an article?
Well, we discussed something like that, but at the moment, because it's it's really new stuff, and nobody actually knows what to do with it. So like saying, "Wow, this is amazing," but just to put this in the right shape and start to use it for like practical for our projects. I think this is kind of the way of thinking that probably we need to come together and discuss how to get it done, because we simply don't understand. We just collected this knowledge, so we are building knowledge graph, but we are not using this knowledge in appropriate way. However, probably in the future we should be able to do that.
Okay.
Yeah, I also liked your slide when you showed like all the nice properties around the IDs where you can actually think of them as, also indexing services, right? They can
Oh yeah,
index containerized, execution environment. Levy here works on this kind of stuff. So you can think of like scientific resources as being much more dynamic objects, right? They can be, you can use a DID to run your API call. How fantastic would that be, right?
yeah,
There's a lot of like really, really interesting potential down the road here. Another thing we've been thinking about is actually you can have a DID and it might have a method, not a DID method, but like a method associated with it with a library that is like dot prompt, right? And then it's like, and in the prompt, it's like, given this stuff that's indexed by this DID, which is really messy, right? Let's say it's like a file structure with like 100,000 files, like a big mess, right? You can say, hey, can you structure this in JSON LD for me, right? Or
yep,
can you generate it in Sparkle and like retrofitted with OWL ontologies, right? So it's almost like a universal key that allows, services that before couldn't interoperate with each other because one was running a completely different data model representation, right? And you could think of that as like the glue piping in between those services, right? Of course, it's really expensive to run, right? Because the query times and all these things, but it's very interesting in terms of like cross services and cross API, cross repository like systems.
yeah. I can even tell you that after I did this presentation in Mexico during Dataverse community meeting, Harvard University also got very interested, and now they're asking me to extend croissant support with DDI variables. So they really want to get all variables collected from, I don't know, 2000 or even like 40 years old, and to understand if they can actually link those variables to something coming from knowledge graph and recognize what it's about automatically. So now they are doing that, and I don't know what will happen, but it looks very promising already.
Yeah, I love it. I think I'm curious, what do you think within all the things you've presented, what are the ones that you think are most powerful or like the lowest, the highest potential avenue to explore when it comes to the intersection of LLMs and scientific data?
I think knowledge graph is something really fascinating because you can get something unexpected after you will create it. I mean, I presented 40 principles of innovation. And what I believe probably we can also use the same principles to teach LM to also to innovate something. So this thing will be inventing things by itself. It's probably like will happen in 10 years, in 50 years, in 100 years, but I'm pretty sure they will go there. So you have data is input, and after you're asking, can you predict what kind of principles you can apply to do something with it? And it will recognize those principles. And what I forgot to mention about this theory, it's about recognizing known approaches from other sciences than yours. So basically, if you have a question and you don't know a solution, you can kind of find solution in, I don't know, in physics or in mathematics by some. So someone already invented it, but nobody knows because it's kind of different terminology, and you don't even understand that it's related to your solution, to your problem, right? So by using this approach and knowledge graph, probably it can point you to specific solution, and after you can kind of apply it for your problem. And this is where it will be like real, it will be a real collaboration between human and machine. This is what
Do
I
you think
believe.
do you think we're at this stage already where I can take, one of these PDF articles from some scientific paper and say, hey, LLM, can you produce, or let's say collection, I have a collection of like, let's say 10 million of them, right? And I say, hey, LLM, please make me a beautiful knowledge graph, right? Which is constrained according to, let's say, something like claims, evidence, hypothesis, for example, right? And you take that structure and you say, take these horrible, human artifacts and turn them into machine actionable artifacts. Do you think we're there yet, or do you think we're still?
I don't think so. You're basically talking about AGI, and I don't think they're there yet,
Yeah,
because
well,
it looks like we need to concentrate more on specific on kind of extracting specific knowledge and building library first. So we
yeah,
need to build
yeah.
knowledge graph on specific for specific disciplines or specific use cases, and after we need kind of interface that will allow to talk, well, different librarians to get them together, and basically they should talk to each other,
Yeah,
asking what do you
yeah,
know
yeah.
about this topic and that topic, and after someone like some artificial intelligence of high level will integrate all this knowledge and produce result. And
Yeah.
for now they're just basically spending a lot of time and burning a lot of credits on putting everything in one model. This is what everybody does. They're spending hundreds of millions on God knows what, and it's not improving because there is no knowledge graph.
Yeah, so Ronan, who's in our community, he made me think about some of the things you are doing, because he's essentially using a nano publication infrastructure to essentially, using LLMs to automatically do semantic tags and annotation on top of it, and then use the LLMs to do all the sparkle things that no one wants to do, right? This is the thing, and LLMs are very good with that. Shackle, sparkle, owl. Like no human programmer in his right mind enjoys this. So it's like a opportunity for a kind of a renaissance. And the kind of core thesis here is that imagine if you can constrain LLMs with a high dimensionality knowledge graph, right? That is a system, like almost like an LLM service, right? So that when an LLM is confronted with information, it can actually pull from these knowledge graphs to construct its answer. And I think it's very promising as an approach as well.
Well, what I forgot to mention is basically about Sparkle. So I did quite a lot of experiments, and I've discovered that Sparkle, well, LM when producing Sparkle thinks that all data should be available for itself. That means that if you have, let's say, a spreadsheet with thousands of cells, it's expecting that every cell will be filled with something. And usually it's not the case. Usually you have missing data, you have corrupted data, and this is where it's failing because it's not getting information that it's expecting from data.
I see. Yeah, the missing value problem.
It's like it's expecting to get like ideal situation, ideal world, but ideal world isn't possible, and we have to do something about that.
Yeah. So probably some sort of dummy code that will let it know that this is
or
something.
randomness, which I presented in the beginning.
Yeah. Actually, randomness is a good way. There's this known theory in training AI models that when they started introducing drop-offs, like the accuracy became bigger, right?
This is exactly the reason why, instead of just having data with some missing values, you can put some random values and it will work.
It might get better.
Yeah.
Yeah. I love that. That's a really interesting property. Yeah, great.
And it sounds like Eric had a question after that, and then Andre.
Yeah, no, I think that the conversation that's going on right now is fantastic. So if it's okay, I'd like to cede my question to others.
Fair.
Okay, so I had a little question about the task I have probably always trying to do when I'm reviewing a scientific article. It's actually the collecting by my own some kind of knowledge graph to refine the bibliography. What do you think? Is it possible to use the, let's say, not a DPID, but for example, PID as an portable resource and to see if there is a bibliography record relevant to the article or not?
This is exactly why we need to use something like DIDs. So to create this resource, and it will be resolvable, it will be persistent, and you can recognize a lot of relationships for specific resource available in knowledge graph. So you can use it for any kind of purposes. You can use it for reviews. You can also kind of get relevant data sets or relevant information related to your resource. So there are a lot of use cases, really.
Yeah, and I could say, so I see here literally the obvious use case about making an DPID and IPFS as the sources of an imported fair data for doing that.
I agree completely.
I think it's really obvious.
Yeah, it's obvious.
And thank you again for the very interesting presentation. It was really fantastic.
Yeah, you're welcome.
Yeah, I'm very curious to experiment. Maybe we'll shoot some ideas your way, Slava, as we experiment with automated metadata labeling, right? Because ideally, the publishing platforms of the future, at least in my mind, right, they allow you to publish any type of arbitrary artifact, and they preserve scientists from having to fill in forms and control vocabularies and all this stuff they don't know and they don't like to do, right? And one of the ways we've been thinking about that is if you have a separation between the data layer and the metadata layer, so to speak, right? You can actually have services that you can ask for a service that says, hey, can you provide me fair metadata, right? And then you go to a service provider, and that service provider will be like, yes, I can, and then issue an attestation signed by the DID key of the service provider that has provided the metadata that is immutably connected now to that DAG, right, on that network, right? And then because it's signed with the DID key, any kind of like entity who's operating in that network has insurance of the provenance, right? So they want to say, well, I trust these people and they've done good jobs in the past, so we will make this metadata a part of our query engine, right, for example. So I think that's really interesting because you start thinking about ways you can break up something that is bundled in something that enables multiple types of agents, either humans or machines, to enrich dynamically, right, the scientific record.
Yeah, that's correct. And I'll also envision that those AI agents, they'll have own identification, let's say, and they'll have all provenance information, which model was used, who is creator, how it's been used in what kind of use cases. So all this information is kind of linked to a specific AI agent, like just in code metadata standard. for software.
Yeah,
So
and
you
think
can get
about
the same.
container, right?
Yeah.
You can have llama in a container, and you can hash that, and now you have the proof that you've actually used llama, right?
Yeah, and
Because you have the hash of the container, and so it's really interesting, right? There's a lot of like really rich provenance systems that can be created.
And after you're replacing llama with something like Mistral, like this fresh model just released a couple of days, right? And you can get completely different results, and still you can link like previous results coming from another model. And this is really powerful because you can also leverage different models. You can just compare them. You can do a lot of interesting stuff already right now.
Yeah, and another thing I'm excited about is like if you're a repository operator, there's no one that can come out from outside the repository to change your metadata. Like you don't want that. You have just one record, and if people mess with it, you have a big problem, right?
Yep.
But that kind of changes the logic because now you can have a repository that's connected to network. Anyone can come in and do whatever metadata. You don't care, right? You don't care at all. You only care about the type of metadata service providers that you trust because it's all signed with traceable provenance. And now you can have dynamic enrichment, and you can break down a couple of the services associated with the scientific record, right, into these more atomic, specialized, service economy, of course, almost, right, in terms of curation.
Yeah.
I had a question about for the knowledge graphs that you've been describing, is there any value in is there any type of like pre-processing step that could be done over, let's say, some subfield on archive or some subset of Wikipedia data or whatever it might be? Is there some kind of massive pre-processing step that would enable you to do what you to accelerate or improve the accuracy or speed of the queries that you're making? And if so, what would that transformation look like?
Yeah, so I already mentioned a few times we're kind of building this knowledge graph from different sources. So it's also coming from metadata published in data repositories with all variables, with all this stuff. And this is quite useful information because, like, if you're talking about the DeSci, you have already quite well-described variables and indicators and all this kind of information, which could be used also to change your prompt and recognize and also rank by importance some words in the prompt, right? So this is like step you're talking about. And we are building this because we are also aggregating a lot of metadata from other data portals. So there is a Sparkle endpoint that actually helping us with that.
Got it. And it's something you're actively building. So like, one question I would have is like, for example, like this is something I've been considering building, and we have something set. We have the beginning stages of it, but it would be good to know if I should go in a different direction with it. We basically have a system there are OCR techniques that already do this. You take a PDF, you convert it to Markdown, and then you can put the Markdown into vector database and just like chunk up every paragraph or whatever it might be. And then you can do that, let's say, for some kind of scientific subfield, whatever. I work in algorithmic game theory, so it's algorithmic game theory. And then I was thinking you can, with this knowledge graph in this RAG database, you can start querying this database to ask questions like the ones you've been describing. Is that something that's already like that? That is, to my understanding, already something that's being built or has been built in other areas. Is there something missing in the ecosystem that would be extremely beneficial for your work and people who are doing similar work?
What is missing is data quality. So like in translation use case, there are a lot of situations where we're not having any kind of translations at all because it's just missing in training data, and probably it's missing everywhere. So instead what they're doing, and I was thinking quite a lot how to solve the problem with missing data. So I've created an agent that connects to Google directly. So instead of querying Sparkle triple store with Sparkle, I'm querying Google. I'm collecting 10 papers on those keywords. So usually they're quite relevant. it goes through pipeline and does recognition on important terms. And after it just does recognition of appropriate sentences, which you can also use an input plus term that it's not translating. And after, in some cases, you are getting quite good results. Not everyone, not everywhere, but so I think this is kind of essential thing that if you don't have information, you don't have data, and you don't know where to find it, right? So you'll just go to Google, and after you should produce knowledge graph out of pages that you'll find in Google, and this knowledge graph should be used to find basically kind of leverage your prompt and also response. This is what I learned.
And what data format would be most beneficial for your type of work? Like would a Pinecone, like vector database be the most useful? Would what would be what would be the easiest to plug into systems like yours that are being built?
I think it should be recognized on the level of knowledge graph itself, because well, with vectors it's not manageable. But with knowledge base, it's quite you can get subset of somewhere in graph, and you can just do whatever you want with it.
So in that case, what are the tools you're using for representations? Are you using semantic web tools? Are you using hypergraphs?
No, currently
databases or
currently there is also another project we're doing with one of American professors in knowledge organization, and it's about building visualization for ancient music, like from medieval music, and we're trying to get all persons, so we're trying to recognize them in different contexts and to understand, for example, if Leonardo da Vinci used to know some other musician, something like that. So based on knowledge graph, right? And we're building visualization for that based on one of 3D libraries. So it should be also working in virtual reality. And this is kind of tool that I think will suit better if you want also to connect all this knowledge and invite human to review it. Because I've seen a lot of libraries, but they're kind of, well, not really accurate and not really helping.
Yeah, so like, what's the database that you're using for storing these knowledge graphs?
Jena Fuseki, as I told in the presentation. It's Jena, triple store plus Fuseki is API on top. Is Sparkle.
Oh, okay. Can you just type it in the chat?
Yeah, thank you. Yeah, thank you.
Jena Fuseki, like that.
Okay, well, that's new.
There are a lot of options, like you can also use GraphDB, which is commercial and quite limited, I think, but it has nice visualization already built in. And there is Virtuoso, which is quite old also and doesn't have nice interface. Some other solutions, like Neptune from Amazon. There are basically a lot of options, but what I like about Jena Fuseki, it's open source and you can actually scale it up if you know how.
Yeah, that's great. That's actually a good resource for us. Yeah, because there's a lot of different way people or backends they use to represent these knowledge graphs. I think the Sparkle side is least popular, perhaps, with developers and nowadays. So they have like hypergraph databases and all sorts of other things. And I guess
there are a lot of modules, like you can also use MongoDB or Neo4j. There are a lot of options, really. And cool. In principle, it should be like compatible between different databases. So it doesn't matter which kind of backend you're using.
Yeah, no, super cool. I think that's super exciting. Levi, we don't hear you. You're muted.
Thank you. So for the actual construction of the knowledge graph, I mean, so you can imagine, okay, so let's say you're in, let's say you take some kind of subfield, let's say it's algorithmic game theory, you convert, let's say, a bunch of PDFs to Markdown, and then you have a vector embedding of every single paragraph or whatever. You could, for example, construct a knowledge graph by taking the like cosine similarity between every vector embedding and every other vector embedding within this entire corpus. And then you have some kind of number between 0 and 1 for every single potential edge. Is that like that's kind of like it seems to me like that's like the naive way of doing it. Are there like more advanced, sophisticated ways? See it, Chris. Are there more like sophisticated ways of doing it? Or like how should this be done? Yeah.
So we discussed this issue a few times, and well, for best way, our researchers kind of invented. They started to feed papers in this workflow. So they're bringing hundreds of papers, and they want to understand if those papers can be linked to some data sets. So by using knowledge graph, you can actually establish this link between something that which was described in a specific paper, and you can find some related data set automatically. At least kind of a prediction, you can make prediction. And by itself, if you'll think about this knowledge graph, it's excellent metadata record. So if you'll put it in Dataverse, it will describe all different variations of the same topic, and probably it can also enrich not only datasets but papers themselves, where people just put in some meaningful keywords on the top. So this is how we are thinking about this right now, and yeah, let's see where it will go.
How do you is this an open source community that you're building this in?
Odyssey is a Dutch national project, and I think everybody can join. So if you want to collaborate, just you're welcome.
Can you put in a link for how?
Yeah, put a link. How would we get involved? Yeah.
Oh yeah.
Perfect. Thank you.
Yeah, so we recently started another project. So Odyssey data is more like research oriented, but we also have infrastructure on top. So it's called ShockNL. This is about social sciences and humanities, and it's even bigger community with a lot of other people coming from different disciplines. So if you're interested to collaborate, there is kind of opportunity also.
Amazing. Yeah, I'm very, I will definitely follow up on this one 100%.
And just another thing, I already mentioned about global Dataverse community, and they are very enthusiastic about building semantic search for all Dataverse instances. And this is where you can also be involved because as soon as we are getting metadata collected from all data providers and we'll start enrich with knowledge graph, right? It will be another kind of record. It will be kind of metadata on steroids. So you'll get a lot of AI stuff already contributed to metadata records, and you have to put some identifier on it. Probably every revision will get own identifier. And this is where you guys you can play this role to provide the PIDs for these kind of purposes.
Nice. This was such a wonderful seminar. There's so many questions and next steps coming out of this. I think especially really like some of the projects we've been doing with like trying to automate metadata for science specifically. So I'm very excited to dig into the resources you have and see how we can build on this to definitely both in terms of the like kind of the LLM aspect and then also the DPID and seeing those connections. But if there's nothing left, then we are past time, and it was super nice. And thank you so much, Slava, for coming and sharing the work that you're doing.
Yeah, thanks for having me.
Yeah, thank you so much. This is thank you for coming.
Okay, thanks.
All right, bye.
Bye-bye.